Hello, great to see you. My name is Usman Sudipyo. I'm the author of article with title Novel Approach on Linear Discriminant Analysis (LDI). This is our co-author Supriyadi Ustad, Pulung, Zainul Fanani, Purwanto, and Muljono. In this presentation was delivered Introduction, Basic Theory, Proposed Approach, Experimental Result, Discussion, Conclusion. Linear discriminant analysis (LDA) is a method used for dimensionality reduction and classification. LDA is a distribution-based method, so it is very sensitive to the influence of outlier. Previous studies offer solutions through improved distribution by replacing or combining L2 norm distance criteria with other criteria that are more robust to the presence of outlier. Although they claim the solution achieves good result, there is no guarantee that the solution can truly separate classes optimally. A novel approach on LDA-based coordinate transformation (LDACT). This approach transforms data from the old coordinate to the new coordinate so that an optimal gradient is obtained which maximizes the separation distance of the two groups in the projection space. Linear discriminant analysis is a method used for dimensionality reduction and classification. This method works by projecting data into lower dimensional space by maximizing class separability. Based on LDA, optimal class separation can be done by maximizing the ratio between the average difference to the number of variants of the two groups and the projection space. LDA based on covariance matrix. This formula is used for classification problems with two classes by maximizing the function jw to get the projection factor. The following is the theoretical basis of coordinate transformation. The following describes how the data is transformed through coordinate transformation into new data. This line equation is used to separate the two data groups, namely the blue dot group and the red triangle. T is a transformation function that maps old coordinates to new coordinates. This is the main formula used for transformation. This formula is orthogonal to the formula above. The proposed approach is to find the equation of the line that can optimally separate the classes through the search for the optimal gradient. The optimal gradient is a gradient from a hyperplane that can separate classes optimally. The equivalent result for the exciting LDA is when the gradient value b. This gradient has not been able to separate the class optimality. The optimal gradient is a gradient from hyperplane that can separate class optimally. The optimal gradient lies between p mu and p sigma, where the effectiveness of setting the gradient value p can be achieved using the following interpolation technique. This section is a very important part to the test empirical whether the proposed new method can be scientifically justified. The optimal gradient value is obtained by running the n value from 1 to 100 and stopping when the distance between the two classes in the projection space reaches its maximum value. The calculation of the distance between two classes is measured based on the difference between the minimum value of the class that has a high class average minus the maximum value of the class that has low class average in the projection space. The dataset for this study is synthetic data without outlier, and the outliers are arranged according to the research need to show the performance of the proposed method. Dataset 1 dimension 2 data with two target classes. Sample size 20 with both classes can be separated linearly. Dataset 2 derived from dataset 1 by adding 4 sample points in the form of outlier in data point that are located quite far from other data group. Experiment using data without outlier. LDA-CT with optimal gradient give good results seen from the ability to separate classes. Blue line can separate the classes well. This result is the same as exciting LDA. The orange line with the optimal gradient show better result with the maximum distance between the two classes, namely 0.7 compared to 0.3. Experiment using data content outlier give good result for LDA-CT with optimal gradient. These results are in line with expectation. Unlike the exciting LDA, it gives bad result. The orange line separates the classes well, while the blue line does not separate the class well. The projection vector of black color is the result of exciting LDA giving the same result with the blue line. Both are orthogonal. Comparison of generalized capability between LDA, LDA-CT, and LDA-CT optimal without outlier and with outlier. From table A and B, it appears that the LDA-CT with optimal gradient gave better result in terms of accuracy and the ability to separate the two classes. The influence of outlier on LDA or LDA algorithm and LDA CT optimal on different synthetic datasets. So the point are experiment result on dataset 1 so that compared to exciting LDA, this new approach has the ability to generalize with the same accuracy level of 100%, but has a separation distance between class twice as good 0.7 compared to 0.33. Experimental results on dataset 2 show that compared to exciting LDA, the LDA-CT optimal method is stronger against the influence of outlier. This is evidenced by the result of the accuracy 91% compared to 75% for exciting LDA. An approach that does not depend on the statistical nature of data distribution causes it to be more robust to the influence of outlier. Thank you for watching.